Hello and welcome to another Blender valve gear tutorial. Today I'm going to show you how to animate this, the joy valve gear. As you can see, the animation plays currently. It's playing, if you should wonder why it plays forward when I play the animation backward, it's because I turned the locomotive around. But I will explain later why I did that. Yeah, you have the animation, and as with the lattice valve gear, you can move the valve gear itself independently. So you can select a lattice, which I named control, and say this should be in full cutoff backwards, full cutoff forwards, or center, or anything between there. And yeah, that's what you're gonna learn today. One thing that I not really forgot, but I didn't think of it while I was doing the lattice valve gear, is to quickly explain how this valve gear works, because maybe it's interesting to know why you have to place something the way you place it, or why you have to make this animation the way you make it. So basically, the joy valve gear, let's go over here, because the reason why I turned this around is the locomotive, or basically lots of the compound locomotives of the London and North Western Railway have upside down valve gears, which, sorry, not that one, which means that I think that's it, apart from that one, which means that the valve is below the yes, the valve is usually below the cylinder, but I turned it around so that you have the usual arrangement. So the general, or the basic principle of the joy valve gear is quite simple. You have the main rod, which is connected to the cylinder on one end and to the wheel on the other, and you have a usually curved link, but in this case it's straight. I will explain later why I made this decision. And the up and down motion of the rod is used to move this part up and down in the link. And just let me check, select the control lattice again. Depending on the angle of the link, as you can clearly see over here, it's currently neutral position. So only the, I think it's called lap and lead, basically the cylinder, the valve are just opening a little bit the ports so that steam enters the cylinder before the piston reaches one of its dead centers on the left or right side. But if I move it, for example, over here, you can see that the motion is, what's the word? It's more extreme. That's not the proper way to describe it, but as you can see, it moves now not only up and down in this link, but also from left to right. And the left and right motion is determined by the angle. And basically the amount of left and right motion determines the cutoff in the end. And as you can see over here, basically if I stop the animation and let's select, for example, over here, where it's the crank is pointing downwards. If I rotate now this lattice and if I change the direction or cutoff, and you watch over here at the valve, you will see that there's quite a difference where it's positioned. And yeah, that's basically the principle of the joy valve gear. And quite similar valve gear is the Hackworth valve gear, where you also have a link which goes up like this. But the motion for basically this rod is not moved by arrangement of other rods. It's moved from a return crank from the main rod or the wheel. But beginning from this point, Hackworth and joy are quite the same. And also, I think it's called Haywood valve gear. Yes, it's the Haywood valve gear, which is also quite similar, because it also have a link and up and down motion transformed into a left and right motion. But yeah, that's basically it for this introduction. As always, I apologize for my bad English. I am not a native English speaker, but I think that you will be able to understand what I'm trying to tell you, because the joy valve gear is, in my opinion, the easiest valve gear of all. So there shouldn't be any problem while you animate this. But yeah, that's it for the introduction, and have fun with the tutorial. So first of all, I start by hiding everything that I don't need now, which means the locomotive, boiler, cap, running plate, and things like that. And by the way, if you should wonder why this locomotive is now upside down, that's because this type of locomotive have upside down cylinders and valve cover, which means that usually the valves are below the cylinders. But that's rather uncommon, so I thought I will turn it around so that you have the usual arrangement of valve gear. Yes, as I said, I just will... By the way, why is it perspective? So I will just get rid of everything that I don't need right now, and basically also this side. Box select by B. Okay, no problem. I will leave that for just a moment. Anyway, first of all, Shift S, cursor to center, Shift A, lattice, move it over here to the... sorry, I have to go down here and select median points so that the moving arrows are in the center of this lattice. Move it in the center of the wheel. Scale it up a bit. Move it a bit upwards. And that seems to be about okay, not perfectly. Scale it down a bit, but yeah, that should do. The next thing is I will duplicate this lattice and move it over here. Scale it down, and I will start naming this lattice over here. Let's call it wheel. By the way, I am not a native English speaker, so I apologize for my bad English. And this also explains why the name of all these parts, for example, this is the abbreviation for the middle crosshead of the middle cylinder, are in German. So if you should ask why there are names or why there are words that you may not understand, it's because they're German. So I will call this lattice control, because this lattice will be used to control the valve gear, basically the cutoff in forward and reverse direction. I will animate it now. Press I and select location rotation. Where was it? Delete keyframes and delete keyframes. I made a mistake. You have to go to frame 1 and location rotation. Go over to frame 30 and rotate this by -360. Yes, I always rotate it just a bit to see if it's a positive or negative rotation. So -360 location rotation, and now it should speed up and slow down. Yes, go to graph editor, press T on your keyboard and go to linear, and that's it. Parent the wheel to the lattice by first selecting the wheel with right click, then shift select the lattice and control P object, and now the wheel should yes, it does rotate. What I like to do now is go down here and change the end frame to 29, because frame 1 is 0 degrees, frame 30 is 360, which is basically the same. So we'll get a little lag in there. But if you change this to 29, it's a smooth rotation. So yes, Shift S, cursor to center. Now we will start with the valve gear, and I will just hide manually without box selecting everything that I won't need. And by the way, if you look wireframe mode, if you look closely, you see that these bolts are not in the center where they should be. Or for example over here, the different rods and levers are where they're supposed to be, or they are almost perfectly positioned. Again, I think it's a exporting issue, because when I was building this model in SketchUp, I made it that everything fits perfectly. And also I don't know why this lever is rotated by 90 degrees. But anyway, I won't need this now. If I want to animate the other side, I would simply rotate it by 90 degrees in this direction. So yeah. Anyway, the main rod, I also don't know why the main rod goes through this part over here. I thought I designed it properly, but anyway, that's just a let's call it cosmetic issue. This won't change anything about the valve gear itself. I will leave this rod for now because I want to show you something else later. But yeah, press 1, Shift A, lattice, and if you press 7 you go into top ortho view. And usually I don't do this because I animate one side, then I delete all, I hide all the lattices, and then I animate the other side. But to make things a bit more tidy, I move it over here so that the lattices for this side are not in the center. So I will scale this lattice down a bit and press Z again. And by the way, why I enter and leave edit mode the entire time, what I noticed is, for example, you see that here are lots of lines, and if you enter and leave edit mode, these lines do not completely disappear, but they are not so annoying. So I will move this over the center of the crosshead. Press Shift D to duplicate it. Press Escape, which does not cancel the duplication. It only cancels the moving. It cancels the movement of the lattice. I press S to scale it down, and Shift D to duplicate it again. And you have to move it now on this. I just realized I made a mistake while. It's not really a mistake, it's a minor inconvenience. But anyway, move this lattice to the center of this rod. You can scale it down again to check if it's in the middle, because when you scale it down, then the distance of this circle, or basically these 4 points on the circle, must be the same distance away from these points on the square, and then you know it's exactly in the center. Parent this lattice to the wheel. And the inconvenience that I was talking about is, it's better to animate this when the crosshead is in the center position, like it's over here. Now it's in the left dead center, but that's no problem at all, because just let me think about it. I'm so silly. As always, I try to overcomplicate things. All I have to do is put it over here, and everything is perfect. Now I rotate this wheel by 90 degrees so that the lattice, which is here, is either up or down in the middle. And now I Shift D. Basically, I like to duplicate these lattices so that I don't have always to edit the Y coordinate. and move this down to, say, let's, for example, 100. And it's up there. I wanted, sorry, of course, minus 100. Shift S, cursor to selected, and Shift A, armature single bone. Tab to enter edit mode, and move this up. If you go down here in the properties panel to this display, I don't know what you call these different, basically what you can open up, and select wire and X-ray, then you will always be able to see this and also the model. Now enter edit mode, press E to extrude, and as you can see, the tail of this bone is already selected. So you select your lattice, Shift S, cursor to selected, select the armature, edit mode, Shift S, selection to cursor, select this point, select this point, leave edit mode, click over here, Shift S, cursor to selected, and Shift S, selection to cursor. Now you have to enter pose mode, which you can either do by going down here and select pose mode or by pressing Ctrl and Tab. And you'll notice that the color of the armature is slightly bluish a bit. So not perfectly blue, but slightly blue. Select this bone over here. You can see it's a bright light blue. And go over here to the bone with the little chain. And I forgot something really important, and I do it now. Because if you rotate this wheel and are not in the ortho view, you rotate it around the axis of your current perspective, which is not good. So I go over here, object constraints, and where is it? There, limit rotation, and select X and Z, and now you can rotate it only around the y-axis. And I will do the same thing for this lattice, limit rotation, X and Z. I will later also limit the Y rotation, but first of all I have to animate everything to check the limits in which I limit the rotation. So select this bone, go to bone constraints, Inverse Kinematics, and you can now press this thing here and select the lattice. And if you play the animation now, you see that it works fine. So I rotate this again to, oh no, it's okay in this position. I just have to move, I just have to move these two lattices where they originally were. Now, next step will be to make the rods and the crosshead move with the animation. So I select this lattice, go to object constraints, copy location, select the armature, go to Bone.001, which is this bone over here, and this lattice will now copy the rotation of the head of this bone. I can change here the amount, or basically if it's 0 it's the head of the bone, if it's 1 it's the tail. Then I select the crosshead, select this lattice, Ctrl P, object. Next I select this lattice, copy location and copy rotation of the armature and the same bone, and down here it's the same again. Sorry, I had to make a little cut. I have felt the urge to, I think it's called the urge, but I had to sneeze and I didn't want to have that on record. But yeah, that's the lattice done. So select the rod, select the lattice, no, not the armature, select the lattice, Ctrl P, object, and everything should work fine. Yes, it does. Perfect. So next step, you can hide this armature by now, for now. Hide, so press H. next step would be to Shift S, cursor to selected. So as I said, I don't have always to do this moving around. Shift A, lattice. Move it over here on this point, because as you can see, I will show you it over here. The main rod has a hole approximately not quite in the center. The center would be somewhere around here, but this hole determines how far the other rods move up and down. But yeah, place the lattice in the center of this of this, which looks about right, and parent it to this lattice over here so that it copies the location, yes, and the rotation obviously. So Shift S, cursor to selected, Shift A, lattice, move it over here. What you have to do now basically is to add lattices at every Shift D at every point where these rods connect with each other. Sometimes you have to add 2 or more, but first of all start with just the ones you need. But for now I can also do this, so that don't have to think anymore about it. Scale it up so that it fits around this link. And by the way, what I have to say while I do with this, I was unable to find proper drawings of this locomotive. So there are quite some locomotives on the London and North Western Railway, which are quite similar but not exactly the same. You want to parent this lattice to this one, Control P, so that when you rotate this, the upper moon moves as well. Yes, there are some locomotives that are rather similar on the London and North Western Railway, and I was able to find drawings of some of them. Oh no, sorry, over here. I was able to find drawings of some of them, and because they are so similar, I will move this G and X over here. Because they are so similar, I assume that if one certain part at one locomotive is like this, for example, then it should be the same on the other, which explains why this is not a curved link as it usually is, but a straight link. Usually you have a curve which is curved in the same radius as the length of this rod over here. But yeah, that's all the lattices done. So go over here, Shift S, cursor to selected, Shift A, armature single bone, and edit mode, extrude. Leave edit mode, select this lattice, cursor to selected, edit mode, Shift S, selection to cursor. I really hope that you can follow what I'm doing here, but yeah, it's basically always the same. I select a lattice, enter edit mode, select the point that should go over there, Shift S, selection to cursor, and that's it. So next thing is enter pose mode again, select this bone. And by the way, you can do this with just one armature, but I like to split it up as much as possible, because let's say for example you animate this with only one armature, and for some reason over here there is an error, or over here the motion goes, for example, glitches through the other parts. Then you have to either you have to find the mistake, or you have to do the entire valve gear again. So if you split it up in several different armatures, then if something happens over here, you only have to replace 2 bones or 3 bones. But yeah, if I play the animation, you see that everything works fine. So I stop it and start parenting again. This lattice stays in this point, so you only have to do the copy rotation. And as this is the first bone of the armature, you select bone and parent this rod to this lattice. And when I say parent, I don't want always to say the keyboard shortcut. So parent is basically select one thing, select the other, and press Ctrl P. If I play the animation, you see this rod follows, which is nice. This lattice copies a location and also rotation. So yeah, both constraints. Select the armature, select the armature, select Bone.001 armature, is it, one question, is it Bone.001 or Bone.001? I heard both variations, so I'm not quite sure. Parent it again. And if I play the animation, yes, it works. So next thing is, select this lattice and parent it to that one so that it basically follows again. Yes, I always like to check if everything works as it's supposed to. And one other thing, there are some locomotives, for example, the Great Western Railway Class 101, which is a 404 shunter, which use a variation of the joy valve gear, and I will explain now how to do this. These variations have a return crank at this point. A return crank is basically you have the wheel, you have your wheel center, and this is the crank, basically the center of the main rod to the center of the wheel. And the return crank means that from this point another part goes, which is mostly known as Walschatz's valve gear, which goes, for example, over here and moves the link. The return crank over here goes, as far as I remember, in the direction of the wheel center. So let's say, for example, over here, which means you have to place another lattice at this point and parent it to this wheel. And all you have to do now is basically the same like this one, only that you have this lattice basically over here is the lattice that is on the return crank. So you have basically, the workflow for this would be duplicate the lattice, parent it, cursor to selected, then armature, one bone over here, the other over here. Then you have to add another lattice on the return crank, which will be used for copy location and rotation for this part over here. And then you have to parent this armature when it's over here to the lattice on the return crank. So basically that the head of this armature follows the return crank. And another thing that's slightly different is that you don't have a hole in, let's hide that one. You don't have a hole in that part, but this rod is connected at this point. So basically you have the hole in the main rod, a rod over here, then this rod goes to the return crank, and from this point it goes up again. I hope that makes it clear. When I do it, as I said, I will redo all the tutorials, and I obviously will do a proper tutorial on the other valve gear as well, but I hope that you understand what I tried to say. So where was I? Yes. Next thing that I have to do is to go over here, Shift S, cursor to selected, and add an armature. That is armature. Edit mode, extruded. Select this lattice, Shift S, cursor to selected, Shift S, selection to cursor, select this point. Leave edit mode, Shift S, cursor to selected, Shift S, selection to cursor. Enter pose mode, select this bone, Inverse Kinematics, and this lattice. Obviously you don't have to click this button, you also can, for example, go in this list and select whatever you like. So now, yes, this works. Now this lattice stays in the same place, so it has only to copy the rotation of this armature and the first bone. And this part should be parented to this lattice. And if you rotate now over the control lattice, you see that everything works fine. I think, if I remember correctly, that it was minus 30 and plus 30 degrees. I'm not quite sure now, but we will check that later. And as you see, on the other side, it follows the same. The next thing you have to do is Z. Select this lattice over, sorry. Oh no, it's this lattice, copy location, copy rotation, select the armature, select Bone.001, and basically Armature.002 and Bone.001. Select this, select this rod and parent it to the lattice over here. And no, not apply the animation. If you go over here, then the rod, the rod should, if I hide this, then no, not T, I wanted to press R, so yes, that works. So basically you only have to do parent this part to this lattice, and if you go into solid view, then you should see that, this lattice, then you should see that everything works fine. So next step, go over here again, wireframe mode, and you have to, sorry, I had to cut again, the phone was ringing, but it was again just somebody who probably wanted to sell insurances or something like that. It really annoys me when that happens, because I go to the phone and I already see the beginning of the number, and I know every number that starts with this sequence of digits is the same fake number. But anyway, next thing you have to do is to copy this lattice over here on the, or basically if you watch carefully, you see that this rod over here is slightly inclined. So it's not always that you have to copy it on the x-axis, but yeah, usually you put this lattice over here when it's a curved link, but as it is a straight link, you move it, let's say 100, and parent it to this lattice over here. If I go now in this drop down menu, I can select it again, so I made a mistake. I really apologize. It should be, minus 100 over here, because yeah, as I said, it should always face the direction in which this rod goes. But yeah, Shift S, cursor to selected, Shift A, armature, single bone, edit mode, and move it all the way over here. And by the way, just to check that I made everything correctly, it's maybe a bit difficult to see, but the lattice moves up and down while I rotate this the control lattice. But yeah, so over here again. Just let me think what I have to do next, because I didn't write it down. For me it's quite logical what the steps you have to do. So yeah, I think yes, that should be the next step. That's the beautiful thing, or that's something I really like about valve gears. You don't have to memorize much, you just have to think logically what would be the next thing that, or basically if you follow the motion of the rods, what's the next motion that's supposed to happen. And that's, in my opinion, that's what makes valve gears rather easy, or in principle rather easy, because it's not too complicated. Even if there are lots of different rods, it's basically just, yeah, what is the next motion, or what is the next movement. So anyway, enter pose mode again, select this bone, Inverse Kinematics, and what I forgot to say earlier, the method of using very, very long bones to make straight lines, which is basically these straight lines are really big circles, but as they have such a large radius, they seem to be a straight line. This was also described by Paul Hobbs in one of his tutorials, but in fact before I discovered this tutorial, I made the joy valve gear, and I was thinking, well, this valve gear has a straight link. What if I make this bone extremely long? Then it should look like a straight line, because first of all, I was doing some very complicated thing with copy rotation, copy location for this one, which basically copied the location of an additional lattice, which I parried it to the crank and limited the location to only move in the X direction, which was rather complicated and for inclined cylinders really not suitable. But yeah, I still think, although I discovered this method independently, that I should give him credit, because why not? I also would like to have the credit if someone uses my method. So yeah. Anyway, back to business. As you can see here, it works as it's supposed to. So select this lattice, copy location and copy rotation, select the armature, and Bone.001, Bone.001, and now you have to parent, if I can, yeah, I got it, this, no, sorry, this part to this lattice, and also this lattice to this part. Just let me check by going over here and again, textured, wire and X-ray. If I play the animation, it should look fine, apart from the fact that over here the bolt is not where it's supposed to be. But yeah. Moving on. The next step would be over here. Select this lattice, press Shift D and move it upwards by, where is it? 100. And by the way, if you have inclined cylinders, you have to do the exact same as with the Walsh's valve gear. So basically moving this lattice up, then parent it to the one that you duplicated it from, and rotate it by the inclination of the cylinders. Anyway, Shift S, cursor to selected, Shift A, armature single bone, edit mode, move it down. Move it down a bit further. Press E to extrude and select this lattice, Shift S, cursor to selected, Shift S, selection to cursor. Do the same over here, cursor to selected, Shift S, selection to cursor. Enter pose mode again, select this bone, Inverse Kinematics. And if you should ask yourself how long it took to develop this method, it was about a week, because if you go over here, you can see something else like follow path. And I originally thought that I have to create some path to follow it, but yeah, basically if you count day one on the day when I first thought about this, or thought about animating valve gears in Blender, and the day when I was able to say, yes, I can now animate every valve gear, apart from some exceptions, but the usual valve gears like Walsh's, Stevenson, Gooch, Joy and things like that. It was about a week, because it's exactly the same as all the other valve gears using Inverse Kinematics, which is fine. You don't have so many constraints. Now, select this lattice, object constraint, copy location, and select this armature. Select Bone.001 and parent the valve rod to this. Now you have the, I think it's called radius rod, which is odd because there is no radius in this link, but anyway. So for that one you have to select this lattice, copy location, copy rotation, and again select the armature, Bone.001, select the armature, Bone.001, sorry, no, select the radius rod, select the, select the lattice, Control P, and I will do now this thing so that I can see perfectly through. And if I play the animation now, everything should work. It's always a bit, for me it's always a bit intense, or I really am nervous because, as I said, you can make mistakes, and for example, if I parent one thing wrong, then it can completely destroy the animation. But by the look of things, I know what's wrong. I know perfectly what is wrong. Let me just check one thing. That is lattice 0.009. So basically this means, go into object mode, and you have to parent this armature to this lattice object, and now everything should work. Hopefully. Let's check. Okay, looks fine so far. Yes, it works. Because you can see that these rods go up and down. I think that maybe 30 degrees was a bit much. Let's change the constraints to -25 and 25. But yeah, that's it. That's let's hide quickly those armatures and the lattices to make it a bit more. Basically I can go over here and where is it? Display only render, and I made a mistake. So unhide everything and hide the loco body and this part, because it doesn't look nice. So there you have it. That's how you animate the joy valve gear. Control lattice. Yeah, as I said, it's quite simple, quite easy, although it uses more armatures than the Walshutz valve gear. But yeah, as you can see, go over here. This rod follows the line perfectly. And yeah, that's basically it. I don't have to say really much more about this. But yeah, so thanks for watching. If you have any questions, please leave a comment. I will try to answer them. And as I said earlier, I will redo all of these tutorials properly. So there will be another joy valve gear tutorial and also a proper tutorial on the variation of the joy valve gear with the return crank. But just a minute, where was my, that is. Why can't I rotate it? Hello? No. Okay, that's strange. Why? No. Ah, okay. I probably was somewhere, yes, somewhere down there, which is not in the area that or in the angle that I'm allowed to rotate. So yes. Anyway, as I said, that's basically it. If you want to see the entire model, I will do this and make it a bit nicer. No. So there you have it. A locomotive with joy valve gear. No, not the locomotive. I wanted to go over here. Yeah, I know it's quite early in the morning, so I apologize if I'm a bit clumsy and confusing, but yeah, that's how you animate the joy valve gear. One thing I forgot to mention, let's hide this one. This locomotive uses outside admission, and stop the animation, outside admission. And basically this point over here, does this make anything clearer? A little bit. This point over here is the center of the, or basically this is what moves in the link. And if you have a locomotive with outside admission, then the attachment point must be extended over this point, which is over here. But if you have inside admission, it must be between this point and this point, so basically somewhere over here. It's exactly the same. All you have to do is this, the lattice over here, move it down there and parent it again to the lattices that is also responsible for this yellow highlighted part. But yeah, that's it for now. Definitely that's it for now. And as I said, thanks for watching and goodbye.